The length distribution of copper rod is shown in table 1. So this is the table 1. We have the length in centimeters grouped into classes from 0 to 4, 5 to 9, 10 to 14, 15 to 19, up to 35 to 39. Then the number of rods in each and every class has been given there. Then you'll be told using an assumed mean of 13, determine the mean and the standard deviation of the distribution, isn't it? So, for us to use the concept of assumed mean, first of all, we need to construct the frequency distribution table. So, in the frequency distribution table, we are going to have the classes. So, we have our classes. The first class is from 0 to 4. The second class is from 5 to the next class, 10 to 14, the next class, 15 to 19, the next class, 20 to 24, the next class, 25 to 29, the next class, 30 to 34, the next class, 35 to 39. Then we will be given the number of rods. So the number of rods gives you the frequency in each and every class. How many rods are in each and every class gives you the frequency, isn't it? So the frequency of the rods in each and every class, we have the column of frequency. The first class from 0 to 4 has a frequency of 3, the next class has a frequency of 4, the next class a frequency of 5, the next class a frequency of 4, the next class a frequency of 6, the next class a frequency of 3, the next class a frequency of 2, and the next class a frequency of 3. Now, we now need the midpoints, the value representing the class, isn't it? So the midpoints we can denote by the variable x. So x will be a value representing the values in each and every class, which will be taken to be the midpoint of each and every class, isn't it? So the midpoint of 0 to 4 is 2, the average of 0 and 4. That is 0 plus 4 divided by 2, isn't it? The midpoint of 5 and 9 is 7. Average there is 5 plus 9 divided by 2. The midpoint of 10 and 14 is 12. The average there is 10 plus 14 divided by 2. If you continue with the same trend, the midpoint of 19, 15 to 19, 17. Midpoint of 20 to 24, 22. Then the midpoint of 25 to 29, the average there is 27. Then the midpoint of 30 to 34, the average is 32. Then the midpoint of 35 to 39, the midpoint there is 37. Now, we've been told to use an assumed mean, meaning we need to use another variable to determine the mean of x and the standard deviation. So we can use the variable d to be the new variable using the concept of assumed mean, isn't it? So we know our new variable d is the old variable x minus the assumed, isn't it? Yes. So the assumed mean, you'll be told this assumed mean you take it to be 13. So the new variable d will be the old variable minus the assumed mean. Are you seeing that? Yes. The old variable minus the assumed mean. So here we are going to have the column of d. So the column of d is going to be x minus 13. So the first x is 2 minus 13. You get? Calculator. Negative 11. The next value of x is 7. 7 minus 13. You get? Negative 6. The next value of d is 12 minus 13. Negative 1. The next value of d is 17 minus 13, isn't it? Yes. Which is 4. Which is 4. The next value of d is 22 minus 13, which is 9. The next value of d is 27 minus 13, which is 14. The next value of d is 32 minus 13, which is 19. Then the next value of d is 37 minus 13, which is 24. 24. So from there, we now have D, of course our D is X minus 30. So from here, if you sum all the frequencies, you are supposed to get the total number N, isn't it? Yes. If you add up all the frequencies, we say N is summation F, isn't it? Yes. N is summing up all the frequencies, gives you the total number of rods, isn't it? Meaning for you to get the total number of rods, you need to add up all the frequencies, isn't it? So if you add up all the frequencies, what is the total number? 30. So if you add up all the frequencies, you get the total number to be 30. So N, which is the summation of N, we found is 30. Now, from here, if you now want the mean, you remember we are using the variable D, isn't it? So if the variable is D, then the mean of D is denoted by D bar. We said when the variable A is X, the mean is denoted by X bar, isn't it? So the mean D bar, because we are using an assumed mean, meaning we are using the D bar, so you see. So the D bar is what? It's the expected value of D. So expected value of D means mean of D. Are we together? So for you to get the mean of D, you are summing all the D values and you are dividing by that total number, isn't it? Are you seeing that? Yes. So that is summing all the D values, and when you are summing the D values, you are summing them with the number of times they are appearing, because some of them are appearing more than once, isn't it? Meaning if you want to add this D value negative 11, you can see negative 11 has a frequency of 3. Meaning you are going to add it 3 times. Are you seeing that? Yes. When you want to add up this D negative 6, they have a frequency of 4, meaning they are 4 there. So if you are adding it, you are adding it 4 times, isn't it? Yes. Are you seeing that? Yes. If you look at this next value, D negative 1, there are how many are they? 5. So when you want to add negative 1, you are going to add it 5 times, isn't it? Yes. So when you are summing D values, you sum them with the number of times they are appearing, then you divide by their total number. Then you find the mean of D, isn't it? So it means for you to get the mean of D, you need a column of FD. You need a column of FD. So can we get a column of FD? So in a column of FD, that is F times D. So here F is 3 times D is negative 11. What do you get to the FD in that row? Negative 33. Here F is 4, there D is negative 6. 4 times negative 6, you get FD to be negative 24. Then here F is 5, D is negative 1. 5 times negative 1, you get FD to be negative 5, isn't it? Then here F is 4, D is 4. So F times D, you get 16. Yeah, F is 3, D is 9. 6 times 9, 54. Then here F is 3, D is 14. 3 times 14, 42. Here F is 2, D is 19. 2 times 19, 38. Here F is 3, D is 24. 3 times 24, 72. Now we need to sum up all the FDs, isn't it? So when we add up all the FDs, what do we get? When we add up all of them, what do we get? Add up all of them. Negative 33 plus negative 24 plus negative 5 plus 16 plus 54 plus 42 plus 38 plus 72. What do you get? 160. So you get summation of these 160. So it means when you want the mean of D, it is the sum of all the D's which you found to be 160 divided by their total number, N, which you found to be 30. And remember, N is just the same as saying you summed up all the frequencies. Still the same thing, isn't it? So N is the same as summation F. Are we together? So it means what is the mean of D? 5.33. You found the mean of D. Remember, if you are looking for the mean of X bar, it is the summation of Fx over summation F, isn't it? So if you are looking for the mean of D, where there is X, you put D. So the mean of D is summation FD over summation F, isn't it? Yes. What summation F is N. Severe. Good. Now, we are now using the mean of D to get the mean of x, because x is what is representing the length of the rod, isn't it? So how do we get the mean of x? Remember, d is x minus 13. So if you put about on top of d, you put about on top of x and about on top of that. Meaning when you put about on top of d, that is the mean of d. You see? So the mean of d is mean of x minus mean of 13. But the mean over mean is just the value itself. Mean of 13 is just 13. So you are adding up 13 and dividing by their total number. You get the mean of 13 to be just 13. So from there you now have, if you make x the subject of the formula, you get x is negative 13 coming this side. D bar plus 13, isn't it? So then you get, for you to get the mean of x, it is the mean of d plus 13. So the mean of x will be, mean of d you found to be what? 5.33, then plus 13. So you get the mean of x to be 5.33 plus 13, 18.33. So the mean of x is 18.33. You just come and get it from that principle where you had the d is equals to the x minus 13. So if you put about on top of d, you put about on top of x, okay? Then you make x bar the subject of the formula, meaning x bar will now be d bar plus 13. So for you to get the mean of x, it is the mean of d you found plus 13, meaning you found the mean of x using the assumed mean approach, because the d values you are getting from the assumed mean. Are you seeing that? Are you together? Meaning that mean of d was the path you were told to follow. Is that okay? Now after that, you'll be told to determine the standard deviation of the distribution. So how do we get the standard deviation? Standard deviation is the square root of the variance, isn't it? And we found that when d is x minus assumed mean, then we found out that the variance of d is always equals to the variance of x. Are you seeing that? The variance of d is always equals to the variance of x. Meaning the moment we get the variance of d, that will be the variance of x. Are you seeing that? And it is the variance of d we are looking for, because the d is what is using the concept of the assumed mean, isn't it? So how are we getting the variance? So what is the variance? The variance of d. The variance of d we say is that the expected value of x squared, isn't it? Minus the mean squared. And the mean, now this is d, so it is going to be expected value of, so do it like this. The variance of x is expected value of x squared minus the mean, which is expected value of x squared. Then where there is x, if you put b, you get the variance of d to be what? Expected value of b squared minus the mean of d squared. Are you seeing that? So if you transform this, what does this imply? Expected value of d squared means you are looking for the mean of d squared. Are you getting that? You are looking for the mean of d squared. And the mean of d squared means you are summing up all the d squares. And when you are summing up all the d squared, times the number of times they are appearing, isn't it? Over their total number. Then it is minus the mean of d squared. The mean of d squared, and the mean of this b bar squared. And b bar squared we've already found. You see? Meaning for you to get the variance, you only need to add a column of fb squared. Meaning if you have a column of fb, all you need is a column of fb squared, then you'll be able to get the variance. Are you seeing that? The column of fb, you'll be able to get the mean. If you add a column of fb squared, you'll be able to get the variance. So what do we have there? For you to get fb squared, see this fb times b. fb times b gives you fb squared, isn't it? See there? fb times this, that is fb times b, you get b times this squared. See there? So fb times b, that is negative 33 times negative 11, you get fb squared. Are we together? No. It is fd times b. This is equal to what? It is fd times b squared. So that gives you fd squared. Yeah, so it means when you multiply the column of FD times D, you get FD squared, isn't it? Which is negative 33 times negative 11?
363.
1?
363.
363.
Yes.
You get 363. Then, D times FD?
144.
144.
Yes.
Then the next, negative 5 times negative 1 is 5. Then the next, 16 times 4?
64.
64. Then the next, 54 times 9? 40?
486.
486.
Yes.
Then the next one, 42 times 14?
588.
588. Then the next one, 38 times 19? 720? 22. Then the next one, 72 times 24? 1728. So we want to sum up all the FD squares, isn't it? So when we add up all the FD square, what do we get if we add them up all? If you add them up all, what do we get? If you sum up all the FD squares, what do you have?
4,100.
1?
4,100.
4,000? 4,100. You get 4,100. So the next thing we do is to substitute the values, isn't it? So we have found that summing up all the FD squared is 4,100. And you divide by the total number n, or summation n, isn't it? The total number n is 30, isn't it? Then it is minus the mean of D squared. And what did you get to be the mean of D? 5 points? So it is 5.33 squared. So what is the variance of D? What is the variance of D? 4,100 divided by 30 minus 5.33 squared. What do you have? 108.26. So you have the variance of D to be 108.26. And that variance of D is the same as variance of X. Have you seen? Meaning, variance of D is the same as variance of X when D is X minus SU. Isn't it? Are we together? So that implies what? It implies the variance of X is what is equals to 108.26 because that is the variance of D. Are we together? Then from there you now get the standard. The standard deviation of X is what you are looking for, isn't it? So the standard deviation of X is the square root of variance of X. So the square root of variance of X is square root of 108.26. You get it to be square root of 108.26 10.40. You have 10.40 to be the standard deviation of the distribution. So everything involving the distribution must be for the X, because it's the X is the variable representing the distribution. D is the pathway, because we don't use the assumed mean approach, isn't it? Are we together? Very good. So that is how to handle such kind of cases when you are told to use an assumed mean. Let us see another case.